Hi, I'm Francesco Vassalli. I am a AI engineer at Jippity. We are a startup that does quite a lot of RAG actually. We generate code for students learning JavaScript. I have never used GraphRAG before, so I thought this was a great opportunity to try that out. So I'm going to present my submission for the ArangoDB Agentic GraphRAG Hackathon. As a quick overview here, I am looking to make a GraphRAG system that basically works as an agent for building up the graph from a bunch of articles that I'm hoping will teach me about a new topic. In this case, I chose the Sudanese Civil War just because it was a topic that I wanted to know more about, and I'm not very educated on. So here we go. So for my data set, I went to the Sudanese Civil War Wikipedia page, but instead of using the Wikipedia page itself, I went to all the sources in the intro section and copy and pasted the article text for those sources into my agent, basically. So the core of my agent is a tool calling system using GPT-4o. Since creating the knowledge graph wasn't meant to be the focus of this hackathon, I'm not going to go into too much detail on that, but you can see here the system prompt I'm using to tell 4o, here's a piece of text, extract out all of the named entities from this text, and those are going to become the nodes of our graph. The second step is then finding relationships between those nodes, and I use a separate system prompt for that in a series of tool calls, basically, to go through and make sure that we're not dropping too many of these. And this is very similar to the process described in the Microsoft blog post in the accompanying paper. So once we've loaded all the sources in using that expand knowledge graph endpoint, we're going to convert that graph into the network X format and attach the ArangoDB backend and persist that in the cloud. So that's all pretty clearly explained in their documentation. Now if we look at the graph at ArangoDB, we're going to basically see the beginnings of the problems with a simple agentic graph creator, which is that this graph is way too sparse. There's too many nodes that have no connections at all. But we're going to double down on the agentic system to see how we can resolve that. We're going to load up the ArangoDB LangChain community package, which supports natural language querying of the graph that we now have in the ArangoDB cloud instance. And with this algorithm, we're going to find nodes that are part of that sparse part of the graph, and then see which of their summary words match with other nodes in the graph, and ask the ArangoDB QA chain to submit a query for adding a edge between those two nodes. So here's what the graph looks like after automatically finding all those connections. It's much denser, which this is going to be good because the Microsoft paper says in the next step, but before we get to RAG, we still need to generate communities and community summaries. And basically communities on a graph are areas of neighbors that are more connected to each other. And this is where cuGraph is going to come in. They have the Luvian algorithm, which is a community finding algorithm. So I can take the ArangoDB backend plugin for the Network X and just directly call the Network X Luvian algorithm to get that cuGraph implementation. I have the communities identified from the Luvian algorithm. We're going to generate community summaries, and here's the system prompt for doing that. And this is going to be useful in the final step of doing the GraphRAG. So now that we have the community summaries, we can actually get into the fun part, doing GraphRAG. And the heuristic is going to be that the user asks some plain text question that gets sent to all the communities to generate community summary, and then the community summaries are summarized into a global answer. But that's just basic GraphRAG as defined by, or as implemented by Microsoft. With ArangoDB and cuGraph, we can implement a hybrid query model where on top of that system, we're also going to query the graph with some simpler heuristics like which of the entities in the question and answer are mentioned in the graph, grab them, grab their neighbors, and then take that subgraph and apply the cuGraph PageRank algorithm and see, okay, what are the influential members here? So we can add this dual context to what the user is asking for. So let's look at a couple examples.
Here's the UI I implemented. It's just a very simple React app with one page to call my Fast API backend. Here's what that code looks like. Make this little chatbot file, take whatever the user gives you as input, post it to this endpoint, return the response. So as a test question, we'll do which groups have switched allegiances during the Sudanese Civil War. Okay, and this thing's going to run for a little bit. So during this time, it's taking this question around to each community, asking the communities if they are relevant for this question. And then for the ones that are, it's going to ask the community to generate an answer. And then going to go through all those community answers, generate the global answer. Then from the global answer, it's going to take that back to the graph and determine which entities from the graph are related to the question and answer, build a subgraph, and then do PageRank on that subgraph. And then write some text to add into the final answer. It's a lot of steps. And the primary bottleneck is in LLM time. I probably could set this up with Grok or something to go very fast, but I just am using GPT-4o. Oh, there is our answer. Okay, so what I want to highlight here is we say this group was aligned with this. This group was neutral and then became in support of SAF against RSF. And then this is that graph part I was talking about. So cuGraph PageRank predicts that Sudan Armed Forces SAF is the most influential entity among those mentioned here. And I guess that makes sense because this group is like switching sides to realign.
We can also compare our concise answer about shifting allegiances to what GPT would say if it wasn't doing RAG at all. So I just went to the GPT playground to see what the response would be, and you see that it doesn't even start to address actually the current civil war until the fourth bullet point here. So we're really shifting what the model is paying attention to by giving all of these documents. And I tried doing this with just ChatGPT as well, and it actually decides to search the internet, and then it found even some of the same articles I used to make the documents. So that one gave a very similar answer.
Okay, I'll keep going with a question to kind of demonstrate the range of this agent, which is going to be a question that wasn't included in the articles. So what is the role of oil in the current Sudanese conflict? And I want to highlight this for a couple of reasons. One, basically, one of the demons of RAG is to get the machine to admit when it doesn't know something, especially if we want to do it very close to the documents or close to our graph database. We want it to give answers based off that. And so if we hook this up to the internet and had it search, maybe this is a question it could answer, but we want to see that it's not a question it's going to answer with this setup. And then second of all is how is all this PageRank stuff going to work if we are talking about things that aren't in the graph, right? So the agent needs to independently be able to determine when is the right time to use the hybrid query model and when is it not time to try to do that. Okay, here we go. So yeah, you see there's nothing about our query there. The provided articles do not tell you the role of oil in the Sudanese conflict. This is super useful too, right? Like if we just want to know what is in some graph database, answers like these are extremely powerful.
So overall, building a agentic GraphRAG system was a fun challenge. I'm glad I got this working, and looking forward to what else I see people doing with it. So enjoy.